All right, so today we're picking up lesson 9.1 at example 2, letter C, all right? So make sure that you have changed the statement in your notes. I extended it, I gave you a little bit more detail, and I want to make sure that you have it down because I think it'll really help, okay? It says you cannot multiply numbers and variables under the radical with numbers and variables that are outside the radical. So with that in mind, let's look at letter C. Now, hopefully you recognize that you have a radical outside of a set of parentheses, and there is nothing between that radical and that parenthesis. So what operation are we going to have to do in this problem?
Multiplication.
Multiplication, all right? Very good. Now, we also have to recognize that there is a monomial outside of a set of parentheses. There is a what inside the parentheses? What type of polynomial is inside the parentheses?
Binomial.
So what property are we going to have to use on this problem? Distributive. So if I'm you in my notes, I'm showing myself until I get really good at understanding. And for some reason, radicals are throwing people off a little bit today. So that's why it might be a good idea to show yourself, yes, there's radicals, but I'm still distributing. The distributive property has not changed. All right? So the question is, I've got the cubed root of -4 times the cubed root of 2. Am I allowed to multiply those two numbers together? Yes, because they are both under the radical. All right? Also, the roots match. Okay, that's important as well. If I'm going to multiply two radicals, the roots have to match as well. And both of these are the cubed root. So we're good, and we can multiply. So we've got the cubed root of, what is -4 times 2? -8. Now we're going to bring the minus sign down so we don't have to worry about forgetting it. What about the cubed root of -4 times the cubed root of 16? Am I allowed to multiply those together? Yes. So I get the cubed root of, what's -4 times 16? Careful. -64. A negative times a positive is a negative. Now, remember, before we start upside down division, we're going to try in our calculators. It is very possible that these are perfect cubes. Is there a number times itself 3 times that will give me -8? So punch it into your calculator and tell me, is there a cubed root of -8? Yes, what is it? -2. Remember, as long as our root is odd, we can have a negative number under the radical. All right, bring down that minus sign. What is the cubed root of -64? -4. Okay, again, the calculator is going to do that for me. Now, what do you notice right off the bat? A double negative, and the double negative becomes positive. So what's -2 plus 4?
2.
+2. Very good. So all of that led me to a simple answer of +2. Now, look at letter B. I have said over and over again, what we learn in the past comes with us in the future. And that's exactly what we have here. So if you're looking at letter D, let's talk about what we have. What type of polynomial is inside the parentheses? A binomial. And that binomial is being raised to what power?
Square.
So what special product are we looking at right now?
Difference of squares.
Nope, not the difference of squares. We just said when we were describing what we were looking at, we gave the answer to that question. This is a binomial that has been squared. So this is the square of a binomial. Okay, now, I don't think it would be a horrible idea for you to write that down. Again, the more we practice, okay, looking for these special products, the better. But this is the square of a binomial. Now, we learned a shortcut all the way back in chapter 7 on how to multiply the square of a binomial. So let's talk through it, okay? What is the first thing we have to do when we have the square of a binomial?
Get 2 parentheses.
Nope. Speak up. We square the first term. So, question is, Luca, what is the first term? First term is 2 times the square root of 5. So we are supposed to square that. So let's go ahead and write down 2 times the square root of 5 squared. Now normally we would just go ahead and we would do the math and we would write down the answer, but radicals are going to change things. So we're actually going to write down each and every step of this problem. All right, so we square the first term. What's the next thing we do? How do we get the middle term?
Multiply the 2.
What's that little equation we've been using over and over again? 2ab. All right, so we're going to bring down that minus sign and we're going to do 2 times a. What is the a term in our original problem?
2 square root of 5.
2 times the square root of 5 times the b. What is our b value? Now remember, it's not negative 4 because I already brought the negative sign down. So it's just 4. Good. Now, I'm going to go ahead and put a plus sign because I know, and hopefully you know by now, the second sign is always going to be positive in this square of a binomial. And what am I supposed to do to finish this off?
Square the second term.
Square the second term. And what is the second term?
Negative 4.
-4. Now this time it is the -4 because I haven't brought a negative sign down. Okay? So, according to our order of operations, what do we have to do first? Exponents. All right? Very good. So we've got 2 of them. We've got an exponent here and we've got an exponent here. Now, let's go ahead to the end. Let's do the -4 squared because that's really simple. What is -4 squared?
16.
Positive 16. Awesome. And then we're going to go ahead and bring down the -2 times 2 times the square root of 5 times the 4. Because we're not doing anything with that right now. Now, this has been the struggle all day long right here. If I am supposed to do 2 times the square root of 5 and I'm supposed to square it, what does that actually mean? 2 times the square root of 5, because that's my base, times 2 times the square root of 5. Now, nobody should struggle with that, okay? Because what is 2 squared? 2 squared means 2 times 2, right? Which is 4. So 2 times the square root of 5 is the base. So I take the base times itself. So 2 times the square root of 5 times 2 times the square root of 5. Now I want to make sure I've got room. So I'm going to move this out just a little bit. Okay, I've got 2 times the square root of 5 times 2 times the square root of 5. Good. Okay, now let's talk about this. Let's talk about what we actually get when we do 2 times the square root of 5 times 2 times the square root of 5. What am I allowed to multiply together?
The outside stuff.
Okay, give me specifically, Gage, what I'm allowed to multiply together.
The 2's.
The 2's, because both 2's are outside of the radical, so absolutely I'm allowed to multiply them together. What is 2 times 2?
4.
4, okay? Olivia, what else am I allowed to multiply together? It's not a 5 and a 5. How do we read that? Got to be very good. What is the square root of 5 times the square root of 5? The square root of 25. Very good. Now we bring down -2. Actually, let's not bring it down. Let's actually do the math, okay? We've done our squaring, okay? We've done 2 times the square root of 5 times 2 times the square root of 5. So now let's focus on this next part, okay? What are we allowed to multiply? That's what we have to keep asking because we can't just go and multiply everything. What are we allowed, Emma, to multiply in this next part? Everything outside the radicals can be multiplied. So that's -2, that's 2, and that's 4. So what is -2? And actually, we don't even have to talk about the -2 because I already brought the negative sign down. So 2 times 2 times 4. What does that give me, Emma? 16. And of course, you can't do anything with the square root of 5 but bring it down. And we bring down the rest of the problem, so plus 16. Now, let's go back to 4 times the square root of 25. What is the square root of 25?
5.
So, the 4 that's already on the outside and the 5 that I'm fixing to bring out from underneath the radical, what am I supposed to do with those numbers? Multiply them. And of course, I'm going to bring down the rest of the problem. What is 4 times 5? 20. Minus 16 times the square root of 5 plus 16. Now, is this my final answer?
No.
Why not? I've got like terms. What are they? 20 and 16. So I bring down the -16 times the square root of 5. And what is 20 plus 16? Plus 36. And that is my final answer. Or is it? Can I go any further? Can I combine those two terms? Why not?
It's addition.
That's not why I can't combine them together, though. Why can I not combine them? Somebody raise your hand and tell me, why can I not combine them? Claire. Okay, both terms do not have the same radical. So they are not considered like terms, so I cannot put them together. All right, very good, Claire. Any questions? Now, the next thing we're going to look at is rationalizing the denominator. Either remember this or go back to the beginning of your notes, okay? At the very beginning of our notes yesterday, we talked about a problem that's in its simplest form. There were 3 things that had to be true for a radical to be in its simplest form. Okay? There couldn't be a perfect square root underneath it, or a perfect cube root, depending on the root. There could not be a fraction under the radical. And what was the third thing that we said could not be in the final answer?
Denominator and fraction.
What could not be in the denominator? Everybody look back. It's right there. I want to see everybody. I haven't seen anybody flip back yet. I want to see everybody flip back to where the beginning of the notes where it says simplest form, and it gave you those 3 things. Okay, what was the last thing in that definition? Okay, so what cannot be in the denominator of our answer? A radical. So what happens when there is a radical in the denominator? We have to do what's called rationalizing the denominator. And that's what we're going to look at next, okay? We're going to have either a monomial denominator or we're going to have a binomial denominator. So real quick, if it's a monomial denominator, how many terms are there in a monomial?
1.
And if it's a binomial denominator, how many terms are in a binomial?
2.
Awesome. So here's what we're going to do. Let's focus on monomial denominators first. We are going to simplify the numerator and denominator if possible. We always do that. We did that yesterday. We always want to work the problem out, simplify it as much as we possibly can. Then we're going to multiply the given fraction by a new fraction. Okay, awesome. So what is the new fraction going to be? The new fraction is going to be the given denominator over itself. So I want you to highlight denominator over itself. Whatever your denominator is, you're going to put it over itself and create that new fraction. And then you're going to multiply the numerators and multiply the denominators. That's good old-fashioned elementary multiplying of fractions. All right, so let's focus on example 3. Let's look at A, B, and C first. Monomial denominators. So if you look at letter A, is there anything that we can do to simplify this fraction any further? No. Okay, square root of 5. 5 is a prime number. Can't do anything. But I can't box this in and say, oh yeah, here's my final answer, because what is in the denominator of this fraction? And can I have a radical in the denominator? So I have to rationalize it. So we're going to multiply by a brand new fraction. Now, according to our notes and what we just said, what is that new fraction going to be?
Denominator over itself.
Okay, denominator over itself. Awesome. So Esther, what's the new fraction going to be for this problem? Very good. Square root of 5 or the square root of 5. Okay. Now, you know what? I forgot something. All right. Go back to letter D on example 2. And I forgot there is a shortcut that I want to teach you. Okay. I'm going to teach you a shortcut that's going to help us when we rationalize the denominator. All right. Go back right here to where we did 2 times the square root of 5 times 2 times the square root of 5. Okay. Ultimately, when we multiplied a radical times itself, what did that answer come out to be down here? We have this step in the middle, but I want you to look at, we multiplied the square root of 5 times the square root of 5. We multiplied a radical times itself, and by the end, what did that come out to be?
Whole number.
But what was that whole number?
20.
I circled it right there in that step. What is the whole number?
5.
5. So if I'm going to put this in layman's terms, all right, when I multiply a radical by itself, what is my answer going to be?
The number under the radical.
There you go. So I can skip this middle step altogether. Okay, this is a great note to add. A radical times itself equals the number under the radical. So without having to go through the square root of 5 times the square root of 5 is the square root of 25. Well, what is the square root of 25? That is 5. Okay? Anytime I multiply a radical by itself, the answer is the number under the radical. So let me prove it to you. The square root of 3 times the square root of 3 is the square root of what? 9. What is the square root of 9? 3. All right, you guys give me a number. The square root of, give me any number you want.
5.
Okay? 81. All right, you're going to have to grab your calculators because the square root of 81 times the square root of 81 is the square root of
6,561.
6,561. All right, now, what's the square root of that?
81.
81. So, a radical times itself will always equal the number that was under the radical. Now, let's go back to our example. All right, when we multiply 1 times the square root of 5, what does that equal?
Square root of 5.
What is the square root of 5 times the square root of 5? Based on the shortcut that we just went over, a radical times itself is supposed to equal the number under the radical. So what is the square root of 5 times the square root of 5? 5. And that is my final answer. Now, there's still a radical in the numerator. Is that okay? Yes, absolutely. I just can't have a radical in the denominator. All right, look at letter B. Can either part of this problem be simplified any further than it is? Yes or no?
No.
No. Okay, so I'm going to go straight into multiplying by my new fraction. What is my new fraction going to be, Noah?
The square root of 3 over the square root of 3.
Very good. Now, the square root of 10 times the square root of 3. Alyssa, am I allowed to multiply those two together? Yes, because they are both under the radical. So what is the square root of 10 times the square root of 3? The square root of 30 over, Alyssa, keep going. The square root of 3 times the square root of 3 equals 3. Very good. Because a radical times itself equals the number under the radical. Now, should I try to simplify the square root of 30? Do you think it's a big enough number that we might need to try to simplify it before we box this in? Okay, because our final answer has to be in simplest form. So what do you guys think? You're all staring at me blankly. Yes? No? Okay, let's try it. To me, it's a 30. It's a big enough number that I'm going to at least try. What prime number goes into 30? 3. How many times? 10. And what prime number goes into 10? 2 or 5. 2 goes into 10 5 times. Now, are there any pairs that I can pull out? No. So this cannot be simplified, and this is my final answer. If you look at letter C, it's different in your notes than the problem on the screen. So cross out the one in your notes and put this new problem. The square root of 2y squared divided by 3. Now, what do you notice about what's under the radical in this new problem? What do you see under the radical right off the bat? A fraction. And yesterday we learned when there's a fraction under the radical, what are we supposed to do first? Separate it. So we're separating it to where it is the square root of 2y squared over the square root of 3. All right, now work with your partner to see if you can figure the answer out. First question I have for you, did either part of this problem simplify?
Yes.
Which part?
1, 2.
So the numerator, right? The numerator simplified because the square root of y squared is y. So the y came out and the square root of 2 stayed. And then, of course, the square root of 3. Now, how did we rationalize this denominator? What was our new fraction, Esther? Just the new fraction. Square root of 3 over the square root of 3. Awesome. So, Emma, when we multiplied the numerator, what did we get? The square root of 2 times the square root of 3. So y comes down, and the square root of 2 times the square root of 3 is the square root of 6. What is the square root of 3 times the square root of 3? I shook my head no at the square root of 9 because you're adding that extra step. We're trying to do the shortcut in class today. 3. Okay? The shortcut says a radical times itself is equal to the number under the radical. So the square root of 3 times the square root of 3 is, by the end, is a 3. Okay? This is our final answer. Let's go back to the rules for binomial denominators. Okay? And this is where it gets probably the toughest thing you're going to learn in this section is right here. So really make sure that you are focused. Okay? The first thing we're going to do is simplify the numerator and the denominator if possible. That has not changed, all right? We're right here on binomial denominators. then we're supposed to multiply the given fraction by a new fraction. So once again, we've got a new fraction. So great, where is that new fraction coming from? Well, it's the conjugate over itself, which is great unless I don't know what a conjugate is. So grab your highlighter and highlight the definition of a conjugate. It's the same binomial, different sign in the middle. So we are essentially taking the denominator again and we're putting it over itself, but we have to change the sign this time. Okay? The last step is to multiply the numerators and FOIL the denominator. Now, you'll notice if you look very closely, I crossed out the O and the I on the screen. Cross it out on your notes because I didn't do it in your notes. But in a minute, I'm going to ask you, why would I cross out the O and the I? If we're going to FOIL the denominator, why would I cross out the O and the I? All right, so let's go to letter D. Is there anything we can do in letter D to simplify this any further than it is? No, okay? But what do we have in the denominator that we are not allowed to have?
Radical.
A radical. So this is what kind of a denominator? A monomial or a binomial?
Binomial.
A binomial. So when we go to write the new fraction, we need the conjugate over itself. So who wants to be brave and tell me, raise your hand, the conjugate for this problem? All right, Abby. 1 minus the square root of 3. Perfect. It's the denominator, but we have to change the sign in the middle. Now, we've got to be very careful when we go to multiply the numerator. 9 times out of 10, here's what I get. Everybody does 8 times 1, and then they bring down minus the square root of 3. But what's the problem with that? This is 8 times, this is a monomial times a binomial. So what do I have to do right here? The distributive property. So do what you've got to do. Draw yourself the arrows, put the binomial in parentheses, whatever you've got to do so that your brain understands this is 8 times a binomial. So I have to distribute it. So what is 8 times 1? 8. Okay, I'm going to bring down that minus sign. What's 8 times the square root of 3? Okay, no negative. I already brought the minus sign down. So what is 8 times the square root of 3?
Square root of 24.
Okay, now, I'm so glad he said that because it's wrong. Okay, but I'm glad you said it. Remember the rule we talked about at the very, very beginning. Am I allowed to multiply a number that's outside a radical with a number that's under a radical? No, so I can't multiply them together. But listen, if that were an x over there, if that was 8 times x, you wouldn't struggle. What's 8 times x?
8x.
8x. So guess what? Remember I said this yesterday? Radicals and variables are very, very similar. If I'm not allowed to multiply 8 and 8 and the square root of 3, then what can I do with 8 and the square root of 3?
8 times.
8 times. I can just put them side by side, and that's multiplication. So it's 8 times the square root of 3. Now, look at the denominators. Remember I said right here we were going to FOIL, but there was no need for us to do the O and the I, the outside terms and the inside terms. Because what, somebody raise your hand, what are we looking at when we multiply these two denominators? What do you notice about the denominators? What's alike? What's different? What do you notice? They're the same except for the signs. So what special product are we looking at? The difference of squares, which is why I don't need to do the O and the I in FOIL. Remember? Because what's going to happen if I do the outside terms and the inside terms? They're going to do what every single time? They're going to cancel out. So why waste my time? Okay? Now, if I have conjugated correctly, I should be looking at the difference of squares every single time. So what are the first terms that I can multiply together? 1 and 1. So what's 1 times 1? 1. All right? Minus. It's going to be minus every single time. So I'm bringing down the minus sign. What are the second or the last terms? We're doing FOIL. So what are the last terms that we're going to multiply together? Square root of 3. So right here we go. Emma, what's the square root of 3 times the square root of 3? 3. The shortcut says a radical times itself equals the number under the radical. So we don't, this is, again, do you see why the shortcut is helpful here? Because I don't have to, if I do the square root of 9, I've got to write that down and then I got to rewrite the whole fraction again and get the square root of 9. So the shortcut is very, very helpful. Now, I have 8 minus 8 times the square root of 3 divided by, what is 1 minus 3? -2. Now, got to be very careful here, all right? Because remember, all fractions must be in their simplest form. So here's what you have to understand. Since there is a binomial in the numerator, that denominator goes with both of those terms. So essentially, this is what I'm saying. This is 8 divided by -2, and then -8 times the square root of 3 over -2. Okay? So if I'm understanding that, then when I'm looking at this problem and I'm saying, can I simplify it? All pieces have to be reducible. Okay? If that's a word. All pieces have to be reducible. So everything outside of the radicals, I have to be able to reduce. So can I reduce 8, 8, and -2? What goes into all of those? 2. Okay? So let's think right here. What is 8 divided by -2? -4. What is -8 divided by -2? +4. And of course, I bring down that square root of 3. So there is my final answer. Let's move on to letter E. Can anything be simplified before we start conjugating or before we start rationalizing this denominator? No. So we're going to multiply by what? Claire, what's the conjugate this time that we're going to put over itself? The square root of 5 plus 2. So we take the denominator and we just change the sign in the middle. So the square root of 5 plus 2. Now, again, be very careful. When we multiply the numerator, what are we going to have to do? We have to distribute. So again, whatever you've got to do to show yourself, this is the square root of 13 times the square root of 5 and the square root of 13 times 2. All right? What happens when I do the square root of 13 times the square root of 5? Am I allowed to multiply those together? Yes, because they're both under the radical. So what is 13 times 5?
65.
So the square root of 65. Going to go ahead and bring down the plus sign. What's the square root of 13 times 2? Good. We talked about this earlier. I can't multiply them together because 13 is under the radical, 2 is not. So I just put them beside each other and they're multiplying still. I just can't do any more work. All right. Over. What happens on the bottom? Noah. Am I looking at the difference of squares again?
Yes.
Yes. So I'm going to FOIL, but I'm going to leave out the O and the I. So what am I multiplying first?
The square root of 5 times the square root of 5.
Which equals?
5.
Good. There's that shortcut again. A radical times itself equals the number under the radical. And bring down the minus sign. What is the last terms that I'm multiplying?
Positive and -2.
So, no, I brought down the negative sign already. So, 2 times 2, which equals? 4. All right. So, I've got, now, before I bring down the square root of 65, do you think that might simplify? Yes, no?
Yes.
I mean, to me, it's a big enough number that I'm going to try it if I'm not sure. So, what goes into 65? What prime number? 5, and it goes in there 13 times. 13's prime. Are there any pairs for me to bring out? No. So the square root of 65 is going to stay the square root of 65. Plus 2 times the square root of 13. And what is 5 minus 4? 1. Do I need a denominator of 1? No, I do not. So I'm going to box this in. Now, I boxed it in, but let me ask you, can I combine those? Are they like terms that I could actually combine? No. Why? What makes them not like terms? They're what? But that's not what makes them not like terms. The radicals are different, so these are not like terms that can be combined. Now, let's look at letter F. All right. Will anything simplify before we start rationalizing this denominator? Yes or no? Why are we hesitant? Can we simplify the square root of 2?
No.
Can we simplify the square root of 7?
No.
So does anything simplify before we start rationalizing?
No.
No. So work with your partner and rationalize letter F. All right. When we rationalize this denominator, what is the new fraction that we're going to be multiplying by? Good. The square root of 2 minus the square root of 7. So negative the square root of 2 minus the square root of 7. So what's happening when I multiply my numerators? What am I doing? I am distributing. Again, please, until that just becomes second nature, keep showing yourself so you don't forget. Okay, if you forget it, the whole problem is going to be thrown off. So what is 12 times the square root of 2? 12 times the square root of 2. You can't do anything with those, so you just put them side by side. Okay, minus, what's 12 times the square root of 7? 12 times the square root of 7. Now, can I combine these? Why not? Good. The radical parts are different, so I cannot combine them. Perfect. The denominators, am I looking at the difference of squares?
Yes.
So, Luca, what do I multiply first? What is the square root of 2 times the square root of 2? 2. Awesome. Minus, it's going to be minus every single time. Square root of 7 times the square root of 7 is equal to 7. And I have 12 times the square root of 2 minus 12 times the square root of 7 over, what's 2 minus 7? Negative 5. Now, everything outside the radicals, can it all be simplified? No. The 12, and the 5 cannot. So this is my final answer. And that is the rest of 9.1.